Welcome back, everybody. Today we're doing problem 35, searching insert position, and this time we're going to be doing it in JavaScript. This was a problem given by Amazon in a coding interview. Now let's read the problem and then we're going to figure out a solution as usual. Given a sorted array of distinct integers and a target value, return the index if the target is found. If it is not found, return the index where it would be if it were inserted in the correct order. Now you must write an algorithm that's going to be a runtime complexity of O log n. Okay, so let's actually go through the solution. Now I am going to go through this example here just so you understand what we're doing. So 1, 3, 5, and 6. Now one thing that is very important to note is I cannot seem to find it. Given a sorted array, there we go. So given a sorted array. Now this thing is very important because if the array is actually sorted, I'm able to split it in half, take the number either from the left or right, it doesn't really matter. And I know that everything on the right side of this element that I took is going to be bigger than the element itself, right? So I'm just going to write it here, bigger. And also this is telling me, of course, since it is sorted in the correct order, that everything on the left side is going to be smaller. So small. And this is going to give me the opportunity to see if I'm searching for 5, I'm going to take the right half. And if I'm searching for something, for example, less than 3, I'm going to take the left half. So if I'm searching for 5 here, since this is going to be the target value, I am going to take the right half of 3, and I am going to be ending up with 5 and 6. All right. Now I can take the half of these, so 2 elements, and I'm just going to take the first one. I'm going to check, is the first one the element that I'm searching for? Yes, so here I'm just going to return 5. Now keep in mind that if it's not, or if this was quite bigger, now if I have 1, 2, 3, 5, 6, 8, and here I'm going to say 9, and I'm searching for, let's say, something big. I'm going to go with 9. Now 9 is going to be my target. So let's just write it down so we know what we're searching for, target. And I'm going to take the middle element, and the middle element is going to be 5. Now I know that I'm searching for something bigger than 5. That is why I'm going to take this thing over here. And in the second iteration, I'm going to have 6, 8, and 9. Okay? So now I'm still searching for something bigger than the middle element, because the middle one is going to be 8. And I, again, am going to take the right part of this, which is going to be 9. And then, of course, I'm just going to return. So that's pretty much what we need to code up. All right, let's go and try to see it in code. That's going to get, I think, a bit brighter. The first thing that I do want is to keep a low pointer and a high pointer in order for me to actually change the borders. So I'm going to say just start, or I can go left and right. I think left and right is going to be better. Left is going to be equal to 0, and the right is going to be nums.length minus 1. Once again, I do want to have the first element over here, and for some reason I'm not drawing. I want to have the first element here, and you're going to see it in code far better, but the first element and the last. Now, if I take the first plus the last divided by 2, I'm always going to take the middle element. And if I move the left border to the right or the right border to the left, I'm actually able to sustain the borders, make them either smaller or bigger. And of course, I want them to make them smaller. Each and every time they're going to be 2 times small as the previous one, and that is what is going to make it a log n runtime complexity. All right. In order for me to establish the loop, I'm just going to say while, and I'm gonna write while left is less or equal than right. And now we need to create the middle element. So that's going to be the middle point. I can just say mid or middle. Let's go with the middle element. This is going to be left plus right divided by 2. And since this is JavaScript and it's going to give me 2.5, I'm just going to say mat trunk over here, just to be safe. All right. And now I need to check. So if the nums of middle element is actually equal to our target, obviously I have found it, and I am just going to be returning, as you can see here, the index 2, because I have found 5. Now this is the best case solution, right? I'm just going to say return middle element. Middle element, this is going to be the index that's going to be pointing to our middle element, since that's what we're required to return. And here is the interesting part. This is the borders. Now I'm going to check if nums of middle element, did I write this correctly? Yes. So if nums of middle element, 3 for example, is bigger than 5, and actually let's go with the example. If 3 is actually going to be smaller than the target, I need to put the left border above 3. So this is going to give me 5 and 6, because again 6 is not going to move, only 1 is going to move on the place of 5. So if nums of middle element is actually bigger or equal than, no, actually not equal, I don't want to write that. If nums of middle element is actually smaller than the target, then I need to say that our left side is going to go forward, meaning this. My left is going to go not to the middle element, but one step further. And keep in mind, I'm going one step further because I have already tried to find if the middle element is actually the target, meaning that it is not. That's why I'm just going to skip it. And else, I'm just going to say right is going to be equal to middle element minus 1. If I have not found anything, right, no matter how big the array is, I am just going to return left. And I'm going to be returning left because I have found the place where the target would be. All right, let's run the code and see if this is going to work. Good. Use example test cases. And hopefully everything is going to be all right. All right. Well, that was the problem explained and coded in JavaScript. Thank you for watching. And if you have any questions, leave them down below. Bye.